Welcome. We will start with very basic question and then go in detail. First question, what are the important in-process checks performed during granulation process? Here is the list of 10 important in-process checks. First, moisture content analysis or LOD or loss on drying. Second, particle size distribution measurement. Third, bulk density testing. Fourth, tap density measurement. Fifth, granule hardness assessment. Sixth, granulation endpoint determination. Seventh, granule flowability analysis. Eighth, binder content verification. Ninth, pH measurement of granulation mix. And 10th important point is visual inspection of granule characteristics. Which USP chapters are referred for granulation in process checks? You can refer below table for 6 important granulation in process checks along with USP chapters. What should be the frequency for in-process checks done during granulation process? Established procedures like BMR and SOP shall be referred for frequency of in-process checks. In-process checks should be performed at regular intervals during entire granulation process like every 30 minutes or hourly. Frequency for in-process checks shall be based on the product development. How is loss on drying, that is LOD, is measured in the granulation process? LOD is measured by weighing a sample before and after drying with the difference in weight representing the moisture content. What is formula to calculate percent loss on drying? Here is the formula for percent LOD. It is initial weight minus final weight divided by initial weight into 100. How loss on drying can be adjusted during granulation process? Operators can adjust drying parameters, granulation time or the addition of binders to optimize moisture content and enhance the quality of granulated material. What is the acceptable moisture range in granulation processes and how is it determined? Acceptable moisture range vary by product but typically fall between 1 to 4%. Determination is based on the specific requirements of the formulation and final product. Why is controlling moisture is crucial or important in granulation? Moisture control is essential for achieving uniform granules, preventing agglomeration or overdrying and ensuring product stability and quality. What is the typical range of bulk density values in granulation and how does it vary with the different formulations? Bulk density values typically range from 0.2 to 0.6 gram per ml, but specific ranges vary based on the nature of the formulation and desired tablet characteristics. Can variation in bulk density affect the compressibility of granules during tableting? Direct answer is yes. Variation in bulk density can impact compressibility, influencing tablet hardness and disintegration rates. How is tap density measured and what equipment is commonly used in granulation processes? Tap density is measured by tapping a container containing the granules until minimal volume change occurs. Common equipment includes tap density testers. What factors can lead to fluctuations in bulk density during granulation process? Factors include variations in granule size, moisture content and the presence of fines or agglomerates. During tap density measurement, what is fixed drop height and dropping speed? As per USP chapter number 616, density tester provide a fixed drop of 14 plus or minus 2 mm at a nominal rate of 300 drops per minute. How is the granulation endpoint typically determined during granulation process? The endpoint is often determined by monitoring parameters such as granule size, moisture content, and the appearance of the granules during the process. Why is it important to avoid overgranulation in granulation process? Overgranulation can lead to excessive particle size reduction causing issues such as poor flowability, increased dust formation and difficulties in downstream processing like compression. How does the appearance of granules change as the granulation endpoint is approached? Initially, granules may appear powdery, but as the endpoint is reached, they become more spherical, exhibit improved cohesion, and shows enhanced flow properties. How is particle size distribution typically measured during granulation? Techniques include laser diffraction, which provides rapid results, and sieve analysis, which separates particles based on the size, offering a traditional yet effective approach. What impact does particle size distribution have on compressibility of granules during tablet manufacturing? Particle size distribution influences the packing arrangement of granules, affecting their compressibility and consequently tablet hardness and dissolution rates. How does the particle size distribution influence the dissolution profile of tablets in pharmaceutical formulations? Smaller particle sizes can lead to faster dissolution rates, impacting the bioavailability and therapeutic effectiveness of the active pharmaceutical ingredient, that is API. How is granule flowability typically evaluated during granulation? Granule flowability is often assessed using techniques such as Carr index or Hausner ratio, which measure the powder's flow properties. What is the formula for Carr index and Hausner ratio? Carr index is equal to tap density minus bulk density divided by tap density into 100, whereas Hausner ratio is tap density divided by bulk density. What factors can influence the flowability of granules in the granulation process? Factors include granule size, shape, moisture content, and the presence of fines or agglomerates, all of which affect the interparticle interactions. How does poor granule flowability impact the efficiency of tablet manufacturing? Poor flowability can lead to challenges in uniform filling of tablet dies, resulting in weight variation, inconsistent tablet hardness, and production delays. What are the key aspects to be observed during visual inspection of granules? Aspects include granule size, shape, color, and the presence of agglomerates, which collectively impact the overall quality and performance of the final product. How is dissolution testing typically conducted for granulated materials? Dissolution testing involves exposing granules to a specific liquid medium and measuring the release of the active pharmaceutical ingredient over time, often using a dissolution apparatus. What factors can influence the results of dissolution testing of granulated materials? Factors include granule size, binder properties, and the presence of excipients, which can impact dissolution rates and overall drug release. Describe the importance of blend uniformity in tablet manufacturing. This uniformity is essential for achieving accurate dosage in each tablet, promoting therapeutic efficacy and avoiding potential safety issues related to uneven drug distribution. Why is dissolution testing important during the granulation process? Dissolution testing is essential to assess how quickly and completely a granulated formulation dissolves, providing idea about drug release characteristics and bioavailability. What procedures are used for binder content verification and pH measurement of granulation mix? Binder content verification is done by analytical techniques such as HPLC or titration to measure binder content, whereas pH measurement of granulation mix is done by using a pH meter to measure the acidity or alkalinity of the granulation mix. Last and very important question, why in-process checks or testing is important in granulation process. In-process checks or testing in granulation process supports adherence to good manufacturing practices and regulatory requirements, contributing to the overall efficiency, reproducibility, and reliability of the granulation process. Keep watching FarmGrow. Subscribe to channel for more videos related to our pharmaceutical industry.